How do rockets work? Well, there is a common misconception that anytime you have something moving or accelerating, you need something to push against. And it's understandable that we have this misconception because that's how almost everything that we're used to works. And so let's look at an example that we're all used to, which is riding in a car. When we're in the car, how does the car get moving? Well, we know that the wheel applies a force against the road. And so we would represent that as force, wheel, road. But due to Newton's third law, we know that there's an equal and opposite force, a force from the road onto the wheel, which is applied to the car, and that force is what accelerates the car. This also happens for flying objects whenever you don't have something solid to push against. If we look at something like a helicopter. In the example of the helicopter, the rotors of the helicopter are going to push against the air, and so we might say that's the force of the rotors against the air. But we know that there's going to be an equal and opposite force from the air onto the rotors that is going to be what lifts the helicopter, and in this case opposes gravity. And this is a very common misconception, and in fact in the 1920s when rockets were being developed, many people thought they wouldn't actually work for space flight because there's nothing in space to push against. In fact, there is an editorial published in the New York Times in 1920 that read, "That Professor Goddard, with his chair in Clark College and the counterancing of the Smithsonian Institute, does not know the reaction of action to reaction and the need to have something better than vacuum to push against which to react. To say that would be absurd. Of course, he only seems to lack the knowledge that is ladled out daily in high school." That was only retracted after we had already been to the moon. And so this is a fairly common misconception and one that we need to understand. And so let's try and figure out, how do rockets actually work in vacuum? Well, to do that, we're still going to use something related to Newton's third law. Newton's third law says for every force from object A onto object B, there's an equal and opposite force from object B onto object A that actually arises from something that's known as the conservation of momentum. So that's what we're going to start with. We're going to start with the conservation of momentum. The conservation of momentum says that the time derivative of momentum is equal to 0. Momentum doesn't change. It's a constant. Well, for us, what we're interested in, right, is we have a rocket and the rocket is firing its engines. And so what we are going to say is that the time derivative of the exhaust gases plus the time derivative of the momentum of the rocket itself must equal 0. We're going to use conservation of momentum to explain how the rocket works. This is absolutely fine. We just go through, and what we're going to find is that momentum, the formula for momentum is mass times velocity. And so we have the time derivative of the mass of the exhaust gases times the velocity of the exhaust gases needs to be equal to the time derivative of the momentum of the rocket, which, again, we can write this momentum as the mass of the rocket times the velocity of the rocket. For our purposes, the exhaust gases will be shot out of the back of the rocket at a constant velocity. That velocity of the exhaust gases isn't going to change. It's always going to be some known velocity relative to the rocket. And so that's going to be constant, but we keep putting more and more mass into them. And so the time change of the mass is actually going to be non-zero. And so in this case, we get this. In this case, both the mass of the rocket and the velocity of the rocket might be changing, so we have to actually use the product rule of derivatives to write this out. But, like I said before, this velocity is defined relative to the rocket. The rocket's velocity relative to the rocket is exactly 0. At this point, what we have is we actually have the definition of the force, mass times acceleration, the force felt by the rocket. And so we write that m dot exhaust times the exhaust velocity is equal to the force felt by the rocket, which we call thrust. And so even with nothing to push against, by pushing gas out of the back of the rocket with some known velocity, we are going to get a force that will accelerate the rocket in that direction.